Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and also good morning to all of the viewers. So I will share with you my paper entitled An Overview of 33 Years of Trends in Space Weather Research, a bibliometric analysis from 1988 to 2021. I am Aznilinda Zainuddin from Space Science and Engineering Research Group, SCER, from the Electrical Engineering Studies College of Engineering, University Technology Marang, Malaysia. Space weather refers to solar events like solar flares, coronal mass ejections, and solar winds interacting with the Earth magnetosphere, causing disruption that impact technologies from satellite to power grid. And this critical field has gained global attention due to its wide-ranging effects on communication, navigation, and infrastructure, despite the importance of qualitative reviews on space weather. There has been limited quantitative analysis mapping research trends and gaps. This bibliometric study, covering 33 years, reveals the key research patterns, identified influential authors and journals, and uncover emerging topics that could guide further investigations in this rapidly evolving field. The study expects to identify key authors, journals, and articles while fostering a clear depiction of the research topic through bibliometric mapping and networks. The following research questions are addressed in this bibliometric review. The first one is, what is the changing trend of the space weather field over a period of time, the growth trajectory, and also the geographic distribution and volume. And RQ number 2 is, which scholars have emerged as the most productive and influenced authors, its social structure of co-authorship status, and the most influenced journal and the most influential articles. And the RQ3 is, what are the major themes in space weather and what are the potential topics that could be examined in the future. In this study, we applied bibliometric analysis, a quantitative approach used to analyze patterns and trends in scholarly literature by examining the publication citations and associated metadata. We gain valuable insights into research output and trends, and using the Scopus database, which contains the largest collection of academic articles, we gathered 3,956 studies on space weather published between 1988 to 2021. And after screening the eliminating irrelevant entries, we analyzed these articles to explore growth trend, author contributions, and citation networks. The structured methodology follows the Prisma flow diagram, ensuring a thorough and systematic approach. This comprehensive bibliometric analysis highlights the evolution of space weather research, offering a broad perspective on the field's development and identifying knowledge gaps for future exploration. For this study, we used Scopus to gather detailed data on space weather publication and exported the results to Excel for further statistical analysis. Key metrics such as total publication, TP, total citation, TC, and H index were calculated to assess the impact of space weather research, and we developed tailored Excel templates for bibliometric analysis, enabling reliable data interpretation. Additionally, we use VOS Viewer to visualize co-authorship network, topic cluster, and citation patterns, providing insight into key authors and research trends. Housing Publish or Perish POP package first supported the citation matrix analysis, and this comprehensive approach allowed us to identify productive authors, uncover related research themes, and provide recommendations for future space weather research direction. The analysis highlights the significant growth in space weather research with 3,956 Scopus Index articles published between 1988 to 2021. It shows three distinct phases, where phase 1 had modest growth with 87 publications, while phase 2 experienced rapid expansion. And largely due to major solar missions like SOHO and Stereo. Publication double every 2 years, reflecting an increased recognition of space weather's importance in protecting modern technology. Despite fluctuating citations rate, the research continues to expand with a peak in 2020 contributing to 10% of total publications, showing an upward trajectory in space weather studies. The analysis of the space weather publication by country shows that the United States leading with 1,701 papers accounting for nearly 43% of total publications, highlighting a strong investment in space weather research. China ranks third with 434 papers, but has fewer citations compared to Germany and France. Despite its high publication volume, Germany and France have higher citation counts, indicating more impactful research. The UK contributes 12% of the total publications, while countries like Russia and Japan, though producing fewer papers, it shows a strong citation impact, suggesting higher research quality. Overall, less than 10% of the publications came from other nations. Figure 4 showcase the global collaboration landscape in space weather research, highlighting increasing participation from lower latitude countries. The visualization map here reveals strong international network with the United States as the central hub, collaborating extensively with nations like Canada, Brazil, Japan, Finland, and Russia. This collaboration fosters knowledge sharing, the innovation advancing in the field. The map emphasizes the growing curiosity and involvement of countries previously less engaged in space weather research. Overall, the collaborative network illustrates a shared global effort to study them and mitigate the impact of space weather on technology and society. This section highlights the most productive and influential authors, journals, and articles in space weather research. Key figures include Antti A. Pulkkinen from NASA Goddard Space Flight Center, the top author with 55 articles and 2009 citations, and Matthew J. Owens from the University of Reading with 42 cited articles. Thomas I. Gombosi from the University of Michigan holds the second highest citation count with 2,636, and other notable contributors include Janet G. Luhmann and Angelos Vorlidas. These insights guide academics in making informed collaboration, publication, and resource allocation decision driving knowledge progression in space weather. Figure 5, created using View as viewer, visually illustrate the co-authorship network in space weather research. It highlights the importance of collaboration with scholars like Matthew J. Owens and Antti A. Pulkkinen, standing out as the most connected, each having 11 co-authoring links. The thickness of the links represent the frequency of collaboration, emphasizing how interdisciplinary efforts enhance the quality of research. This collaborative nature allows researchers to pool expertise and tackle complex problems. The map underscores the critical role of cooperative networks in advancing space weather research and fostering innovation, showing that few researchers work alone in this field. The analysis of these academic journals in space weather research offer fascinating insights into their impacts and influence. Space weather, with 573 publications and 9,888 citations, stands out as a key player, boasting a high citation score of 7.30, reflecting its strong academic presence. However, the Journal of Geophysical Research Space Physics, with fewer publications, has 40% more citations. signaling its greater individual article impact despite a lower average citation score of 5.30. This reveals that while publication volume matters, citation trends provide deeper insight into a journal influence over time, showing the nuance and fluctuating nature of scientific impact. The list of highly cited articles in space weather research highlights the significant impact of collaborative efforts. With most articles involving multiple authors, the top article, which is the Solar Dynamic Observers SGO by W.D. Pesnell et al., has 1,681 citations and an average of 186 citations per year, emphasizing its enduring influence. Other top articles focus on space mission like Stereo and Themis, showcasing the importance of missions in driving scientific inquiry and international collaboration. The high citation count reflect the broad appeal, scientific merit, and technological advances. These studies contribute to solidifying their role in advancing space weather research. The analysis of space weather research reveals 5 key themes, which is first the geometric variations, and we have solar activities, solar radiation and space environment, and ionosphere. These interconnected themes explore Earth's response to external space influences, such as solar storm and magnetic field fluctuations, and their effects on communication, navigation, and space technology. The multidisciplinary nature of space weather research highlights the importance of collaboration across these areas to enhance understanding and improve forecasting. As the field progresses, these interconnected themes will guide future research, helping to protect technological infrastructure from space-related threats. Future topics in space weather research based on the recent keyword trends highlight potential areas of deeper exploration. Keywords such as space radiation, equatorial plasma bubble, and geometrically induced current GIC, UV radiation, and AI-related terms like LSTM, deep learning, and neural network indicate emerging topics. With advancement in artificial intelligence, AI, there's significant potential to improve space weather forecasting, accuracy, and insights. AI tools like machine learning and deep learning can help researchers analyze data more efficiently, making it crucial for future space weather studies to integrate AI to better predict and mitigate space weather impact on technological and infrastructure. So with that, we have come to the conclusion, which this analysis provides a comprehensive overview and answer the 3 research questions. And it provides a comprehensive overview of the rapid growth in space weather research. It highlights the significant contribution, influential publications, and global collaboration driving in the field. With growing public concern, especially after events like the Carrington event, the need not to protect modern technology from space-related disaster is clear. The study emphasized the multidisciplinary nature of space weather research, revealing opportunities such as space radiation, plasma bubbles, and AI application. The analysis stresses the importance of collaboration and advanced methods like AI to strengthen space weather forecasting and safeguard technology. So with that, I would like to acknowledge all of the co-authors, and the authors would also like to thank University of Technology Mara and also the Ministry of Higher Education for their support in terms of the materials and also in terms of financial. So with that, I would like to end my presentation and thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.